This video picks up where we left off in today's discussion about writing equations of parallel lines, but writing those equations in point slope form. So as we already know, whoops, let's get that back. We reviewed the top of the notes that we're going to finish up in this video. We did that in class today. So just a quick reminder, point slope formula, y minus y1 equals m parentheses x minus x1. We know that parallel lines have slopes that are equal, and that's just information I'd actually carried forward from chapter 4. And if I know the slope of a line and I'm given a point, I can quickly insert my known information for m, for x1, for y1, and I can pretty easily write an equation in point slope form. So that's what we worked through today. So we're going to quickly run through doing that for two examples down below, but then we're going to take it a step further. What I'd like to do, and really what the purpose of point slope form is to allow us to ultimately find our way to another form. So we're going to actually wind up using point slope form to take information, specifically information that includes the slope and the point of a line, and then simplify that equation into point slope form. Okay, so that's where we are going today. Things are jumping all over the place on me while we're doing this video. So that's where we're going today. All right, so let's quickly get started. We know that we have an equation, y equals 4x minus 7. We have a line that's parallel to that, so we know the slope of the other line is going to be 4 as well. So we know there's my m. We also know that we have an ordered pair on the line that we're going to write the equation for, and that ordered pair has an x coordinate of 6, so we'll call that x1, and a y coordinate of 4, so we're going to call that y1. And we're simply going to substitute the values into what is necessary in the point slope formula. And I'll just write the point slope formula over here. Y minus y1 equals m parentheses x minus x1. Keeping in mind that we're substituting for m, we're substituting for x1, and we're substituting for y1. Okay, so I'm just doing a quick color coding of everything. So let's quickly do that for both of these equations, because for that matter, I know that this is my m in my other equation. This is my x1 for the point that we'll be substituting in. This is my y1 for the point that we'll be substituting in. So let's real quick get those equations written. Okay, so we're going to do y minus my y1 value, 4, equals, don't forget our slope, because it's parallel, because it's a parallel line, we're stealing our slope from the given equation, equals 4 parentheses x minus our x1 value, 6. And don't forget, if we had to simplify, that would just be a matter of using KCO if needed. Okay, to change any minus and negative into a plus. All right, so let's quickly do that with the other equation. We have y minus, minus a negative, so let's see. I'll put that minus a negative in, so minus negative 2. We'll take care of the simplifying as its own step, but you can do that along the way if you want. Equals, let's see, we have negative 1/2 as our slope, parentheses, x minus, and then our x1 value of 4. So I hope what we just did here is real quick and basic review, okay? So we take a look, there's no simplifying to do in this equation. Oh, we see the simplifying to do right there. There's my KCO, there's the need for KCO. Okay, so our final equation is going to read as y plus 2 equals negative 1/2 parentheses x minus 4, at least for the second equation, okay? So here's our complete equation in point slope form for number 1. here's our complete equation in point slope form for number 2. So here's really where the part that might not be as familiar to you kicks in. So let's take both of these equations and rewrite them. Okay, so we know we have an equation from up above that's y minus 4 equals 4 parentheses x minus 6. And we know we have, for a different line, for problem number 2, we had the equation in point slope form y plus 2 equals negative 1/2 parentheses, x minus 4, okay? We're actually going to make use of skills that we know already. We're really making use of our simplify, isolate, solve process. So we're going to simplify specifically by distributing, okay? And then we're going to isolate as we need to by pushing whatever it says next to the y over to the other side of the equation. So we wind up with an equation that says y equals. That's our equation, y equals mx plus b. So we're taking point slope form and we're moving into slope-intercept form. Now remember, slope-intercept form is y equals mx plus b. Okay, so let's get started. So we have an equation again, point slope form. We're going to convert it to slope-intercept form by first distributing. Now this is, again, the one time we don't simplify, the one time we resist all temptation to simplify we talked about was in point slope form. But now that we're looking to move from that given form into another form, specifically slope-intercept, I actually want to follow through on that temptation to simplify. So I can say y minus 4 equals, and the distributing I'm going to get as a result of distributing 4 into x minus 6 is 4x minus 24. So we blew up the parentheses and we distributed. Now we're awfully close to being to our end result where the equation is in slope-intercept form, y equals mx plus b. And we should recognize that all we need to do to get the y isolated right now is to undo the minus 4 by adding 4 to both sides. Now that conveniently gets rid of the minus 4. It gets us the y isolated exactly the way we want. And it gives us an expression on the other side of 4x. And we should be able to work through negative 24 plus 4 is going to give me minus 20. There's my y equals mx plus b. That's my equation that started in point slope form, y minus 4 equals 4 parentheses x minus 6. And we brought it through simplifying with distributing and isolating by adding 4 to both sides to an equivalent equation, but in slope-intercept form. So we move from point slope to slope-intercept. And notice, this is not by coincidence. Notice that our final equation has an m value of 4, a slope of 4, which should hold true and match with the m that existed back in point slope. Okay, so that is our process of taking an equation in point slope form and converting into slope-intercept. So now that we've gone through it once, let's do it again. So let's go to our next equation, distribute to simplify. So we will get y plus 2 equals, and negative 1/2 times x is negative 1/2 x. Careful of your signs here. Negative 1/2 times negative 4, we know a negative times a negative is positive. And you should be comfortable. I really hope you're comfortable being able to do 1/2 times 2 and realize this, 1/2 times 4, realizing this cross-canceling, and that you get plus 2 out of that. Okay? Now that I've done my distributing, I can move on to my isolating. Well, the isolating in this case requires me to undo the fact that it says y plus 2. So what's the inverse of adding 2? Well, that would require us to subtract 2 on both sides. Okay? Conveniently, the 2's cancel. And I get y equals, that's what I'm looking for, that isolated y equals negative 1/2 x. Oh, and what we can see here is actually the 2's cancel out, right? But that's okay. That just means that our y-intercept is technically a value of 0. So we took an equation, in this case, that was in point slope form, y plus 2 equals negative 1/2 parentheses x minus 4. We distributed to get rid of the parentheses. We isolated to get y all by itself. And we have our final equation equivalent to what we started with, but only now in a different form of slope-intercept. So that is what we're going to get really used to. We're going to get used to recognizing that point slope form actually allows us a way of entering into the process of writing an equation in another form. In this case, slope-intercept form, and down the road when we talk about it, standard form. So that is it for today's lesson. We'll do some review in class tomorrow, and we'll actually do some review of graphing from point slope form. I think it's important that we know how to do that. So we'll see you tomorrow, and leave, just in case you forget, leave the back side of these notes for tomorrow.